Hello, welcome to today's class 11.2 Infinite Series. So, firstly, let's take a look at the definition of infinite series. So, definition 1. After we look at the definition, I will show you what's the meaning of this. Okay. Infinite series means for a given infinite sequence, we know the sequence is a list of numbers from a1 to an and then infinity, right? Infinite terms. And if we add all the terms together, a1 plus a2 plus an plus, then we call this series. This is called an infinite series. Or we just call that series. Let's take a look at the notation. Because it's a sum of all the numbers, so we are going to use the sum notation. The sum notation is sigma n from 1, because infinite terms, to infinity. Or sometimes for simplicity, we just do sum of an. So you can see the difference between sequence and the series, right? Sequence is just some numbers, list of numbers. But series is a sum of all those numbers. Okay, that's the definition. Now let's take a look at definition 2. It's called partial sum. Partial sum is given by this. Sn, here S means sum, so we use S. Sn equals a1 plus a2 plus till an. So n means how many terms we add totally together. Okay, it's called a partial because it's part of the series, partial sum. For example, S3 equals what? A1 plus A2 plus A3, only 3 terms. If we have F5, that is A1 plus A2 till A5, something like that. So that's why it's called a partial sum. And here if we write down, we want to write down as sum notation, that is ak, k from 1 to n. So index here we use k because we want this to be different from the n here, okay? Because we have Sn. This is called the partial sum. Actually, n's partial sum. So on the right side, you can see they are the third partial sum, fifth partial sum, right? Now let's take a look at this series. Here we have a sequence given by this one, an equals 1, 1/2, 1/1, 1/8, 1/2 to the n. We know this is sequence because this is a list of all those numbers, right? And if we add all them together, we get the series. Okay, this is series. Or we can write down 1 over 2 to the n from 1 to infinity. This is the notation, right? And now let's take a look at the partial sum. Partial sum, let's see, S1. S1 means what? S1 means just 1, right? S2 means we add the first 2 terms together. S3 because we add the first 3 terms together. Plus 1 over 4, and we skip the middle partial sums. Let's go to the Sn. Sn equals 1 plus 1 half, 1 fourth, 1 over 2 to the n minus 1. Okay. Now let's see what's the sum are. We are going to calculate the sum. S1 is 1. S2 is 3 half actually. And S3, 7 over 4 if we calculated them. And the Sn is 2 to the n minus 1 over 2 to the n minus 1. Okay. And if we write them as another form, we can write 1 as 2 minus 1, 2 minus 1 half, 2 minus 1 fourth. We just want to write this in a better form. Don't worry too much. We don't need to know how to write down this. I just want to show you what's the sum going to be. Okay. Actually, they are equal to each other, just another way, different way to write down the sum, partial sum. Let's see. When n goes to infinity, what's the sum goes to? Partial sum goes to. Partial sum, let's see, Sn. We can take a look at the last sum, which is Sn, right? When n goes to infinity, 1 over 2 to the n minus 1 goes to 0. Because denominator goes to infinity, whole thing goes to 0. So Sn goes to 2. Right? We can also write down the other way, so it's kind of like, actually same thing, 2 minus, okay, this is Sn, which is limit 2. Different way to write down the limit. So when the partial sum has limit, or the limit exists, we say the series converges, otherwise diverges. Let's take a look at definition 3. If limit of the partial sum Sn is L has limit, we say the series converges. That's the definition for convergence of series. And its sum is L, same as the limit for the partial sum. We write sigma an n from 1 to infinity equals L. This is the sum. Okay. If the limit of the partial sum does not exist, then we say the series diverges. So convergence or divergence of a series is defined by the partial sum. Here, be careful. What's the meaning of sequence? That's the list of numbers. Okay, just numbers. How about series? That's the sum. Sum of all terms. don't be confused with them. Okay, they are different, totally different thing. Series is a sum, sequence is just numbers. Next, we are going to do another definition. Actually, this is another commonly used series. It's called a geometric series. It's a kind of special form of series. Okay, I'm going to show you what the series look like. Geometric series are series of the form look like this. A plus AR plus AR squared plus A times R to the n minus 1. Actually, this is the nth term. Okay. Let's see. And if we write down the sum notation, it is A R to the n minus 1, n from 1 to infinity. And here A is not 0. Otherwise, you can see if A is 0, all the terms are 0. When we add them together, it's still 0. So, no, it doesn't make any sense. Oh, for sum notation, we can also write down this a different way. We can write down this as A R to the n from 0 to infinity. Actually, they are the same thing. Okay, same thing. It doesn't matter which way we write. It just depends on n from 1 or n from 0. But I think the first one will not be easily confused. So you can always use the first one. And the second one just easy to see. Okay. And here R is called a ratio. It's called a ratio. Ratio R here can be positive or negative. And negative. Let's take a look at some examples of the geometric series. Let's look, what do they look like? 1/2 plus 1/4, 1/8. So actually 1/2 to the n minus 1. Let's take a look at this one. Okay. So in the series given here, let's take a look at A. A is always the first term. For the series 1 plus 1/2 plus 1/4, A is 1. Right? And for the ratio, how do you look at the ratio? There are two ways to find the ratio. The first way, you can look 1/2 times what? That's going to be our ratio equals the next term. Okay, 1/2 times what will be 1/4? R equals 1/2, right? The other way, we use the next term divided by the previous term. For example, you can use 1/4 divided by 1/2 or 1/2 divided by 1. So it's kind of like those. And we can also get R equals 1/2. I like the second way better. So always use the next term divided by the previous term, we can get the ratio. That's like AR divided by A, which is R, right? Something like that. Now I'm going to show you another series. This is 1 minus 1/3 plus 1/9 minus 1/27. And the nth term is negative 1/3 to the n minus 1. Actually, this is alternating. Okay. Let's take a look at this series. Can you find A and R? Okay. For this series, we can see A should be easy to find, which is 1, the first term, right? How about R? I'm going to use the second method. I'm going to just look at the second term divided by the first term, which is -1/3. Or you can use the second term divided by the third term, like 1/9 divided by -1/3. We also get the -1/3. Okay, so the ratio is R. So let's see. For the here I give you two examples of the geometric series. The first one, R is 1/2, which is positive. The second one, R is negative. Right? So for geometric series, R, the ratio R can be positive and negative. So they're both correct. Next, we are going to find the limit for the partial sum, or the sum for the series. We want to see what's the geometric series R to the n-1, and from 1 to infinity. What is the sum? Okay, what's the sum? Does this converge? If converge, what is the sum? Now let's take a look at this. See, okay, question. What is the sum? Here we are going to separate this into three cases. When R equals 1, and then R equals -1, and then R does not equal to 1. So the first case, let's see. The first case, R equals 1. What is our series? I'm going to write this out. Our series becomes A plus the next term AR, but A times 1, right? So just A, and plus A, plus our Sn is plus another A. So here, how many A do we have? Sn means n terms. So here we have n_a. So totally the sum, partial sum, should be n times A, right? So when n goes to infinity, this term goes to infinity. So when R equals 1, our series diverges. Next, when R is -1, what is Sn? Sn becomes A minus A plus A minus A. Because it's AR squared, R is -1, so it's always +1, -1, +1, -1. And plus A minus A. Okay, so depends on n is, even number or odd number. It's going to be, this number going to be 0 or just A. If n is odd number, they all cancel out, which is 0, right? If n is even, they all cancel out. N is odd, we have X term, which is A. So the sum alternate between 0 and A. In this case, the sum alternate between 0 and A. There's no limit, right? We also say diverges. So when R is +1, -1, the series diverges. Number 3, so we say when R is not 1, let's see what is the partial sum. Partial sum equals A plus AR squared, AR to the n-1. That is the nth partial sum, right? So we stop here because it's partial sum. And next, how to find the sum? We do this way. Here is a little bit technique, so don't worry too much. you don't need to know this technique. Okay, we times the equation Sn here. Let's say times the star by r on both sides, so it becomes ar plus ar squared, ar cubed, ar to the n, because we times all the term by r, right? And next we say this is equation 1, equation 2. We use equation 1 minus equation 2. That means Sn minus Rsn equals what? Left side equals this thing. Right side equals what? Right side, let's see. Ar minus ar cancel out. Ar squared minus ar squared, they all cancel out, right? And this cancel out with the term in front of it. So let's see, right side, what left? A minus ar to the n. Okay, that's the right side. And now simplify. Factor Sn out. A minus ar to the n. And Sn equals what? Divide by the coefficient in front of Sn. 1 minus r is the coefficient. And on the top, a minus a to the rn. Or we can write down this in a better way. Factor a out in the numerator. 1 minus r to the n over 1 minus r. So this is the partial sum. Partial sum. Next, let's take a look at what's the limit of Sn. Here. If r absolute value less than 1, then we know Rn goes to, do you still remember what's the limit of, let's see, come from 11.1. I think at the end we learn some commonly used limits. And this is one of the commonly used limit. When r less than 1, for example, you can keep this in your mind, goes to 0, right? Goes to 0. So Sn goes to what? A 1 minus 0 over 1 minus r. Simplify a over 1 minus r. And this will be the sum for the series. So we know when r absolute value is less than 1, it converges, geometric series converges, and convert to this number. B. If r absolute value greater than 1, Rn goes to some number greater than 1, for example, 2 to the infinity, it's infinity, right? R to the n goes to infinity. In this case, our Sn goes to infinity, positive or negative, we don't care too much, but we know that's diverges. Okay, so we discussed several cases for the R. We know only for R absolute value less than 1, the series converges. And converge to which number? A over 1 minus r. Please remember this formula. And for r, if the absolute value is greater or equal to 1, that includes r greater than 1, and r equals positive 1, negative 1, right? In this case, the series diverges.